Okay, so my name is Cathy Bodine, and I'm an associate professor in bioengineering at the University of Colorado, and also an associate professor in pediatrics, physical medicine and rehab, and orthopedics. So basically, I serve at the nexus between engineering and medicine, and it's a role that I absolutely love. And what I'm here to talk about today is how the human factors involved in designing technologies in this new world of edge computing, and we'll explain what edge computing is for those of you that maybe haven't heard that yet. And we only have 30 minutes, so I'm going to move quickly. So the first thing I want to make a point of saying is that designing technologies for people with cognitive and other impairments is tricky stuff. It's not for the faint of heart. And it requires a great deal of care and consideration in order to do a really, truly excellent job. So we're going to start, first of all, what is edge computing? Who knows what edge computing is? You heard this term yet? Ooh, got one over there. What is it? Excellent. You go to the head of the class. Exactly. Edge technology, and we just got with my program at CU and Georgia Tech and University of Delaware just collaborated on a National Science Foundation grant, which we just received, to do a one-year planning on developing an engineering research center on edge technology. So I'm pretty excited about it. But what is it? Edge computing is basically this notion, if you think about all the sensor technology that's out there and all this cool stuff that's happening, the one thing that all of these technologies have in common is they're capturing massive amounts of data. They're manipulating massive amounts of data. And if you have to send all of that data in one chunk to the cloud, what happens with your speed of processing? You have lots and lots of data. What happens? Slows down. That's right. Edge computing essentially breaks up that data, and it gets processed locally in smaller server settings, right? And then it can be uploaded to the cloud. That's where we get our real-time, instantaneous feedback. That's where we get everything we need. So if you're in disability technology like I am, your brain is going nuts because you're thinking all this cool stuff we can now do with this, because it's going to make this data make sense. And I do want to point out, for the first time in the history of cognitive technologies in particular, we now have lots and lots of data. But we have to know what to do with that data, right, in order to create technologies that are going to be useful and usable by people with cognitive impairments. And so it's a really cool new challenge. It enables us to do things we couldn't do before. And so for the people that are futurists and folks that are really out there thinking, the little wheels are turning right now. What it means is it's better and it's faster. And when you think about IoT or Internet of Things, all these sensors, all these things I'm talking about, for example, autonomous vehicles, how many millions of data points are going on every minute in an autonomous vehicle? And if we want to have it accessible for people with cognitive impairments, what does that mean if maybe they don't understand what they're hearing, or maybe they don't know how to say where they want to go? What does that mean? For smart home technologies, where we have security, we have healthcare monitoring, we have all kinds of, we just heard in our keynote about some really interesting home service provision and home help that can be occurring remotely. What about robotics? We're building social assistive robotics in my labs now to help kids birth to 3 with severe neurodevelopmental disabilities. How can we use this data faster, better to make all these technologies work? And more importantly, how do we have history repeat itself? How many of you knew that voice output on a computer was developed not for mainstream, but for people with disabilities first? Did anybody know that? I knew Larry would know. The 2 people, yep. Okay, it's true. Back in the day of DOS computers, for people who were blind, who needed to hear what was on their computer, I think it was JAWS originally, wasn't it? I can't remember the original first. I think it was JAWS. JAWS was created to help people who are blind use a computer. Who uses voice output on their computer today? Everybody. Okay, same thing with voice input. Voice input was originally designed for people with high-level spinal cord injury who needed to talk to their computer. Who uses voice input? I used it on my way here this morning, right? Okay, that's what I mean by saying I want history to repeat itself. I want us to develop the technologies of the future that everybody's going to want. And there's good reason for that happening in terms of the cognitive space because of our aging population, right? By 2035, 1 in 5 Americans will be over the age of 65. So that means we're going to have those natural things that happen with our cognition and other body parts as we age. Well, some of those functional characteristics are going to be reminiscent of some of the functional characteristics we deal with other people with cognitive impairments. So it's interesting. But, there's a big but. Exclusionary design matters. And what is exclusionary design? Exclusionary design means we leave people out of the pie. There's a big chunk missing. That's not good. And so there's something my friend Yuta Treviranus, and if you get a chance to hear her speak, she's fantastic, talks about, and that is this notion of outliers. And so if you're into research, you know that when you aggregate all your data, the idea is everything kind of regresses to the mean. In other words, we have this big old clump of data that kind of shows what's going on with our research. But every once in a while, there's a dot over here on the graph. That's called an outlier. People with cognitive disabilities, I believe, are treated as though they're outliers in many situations. It's not fair and it's not right. So what do we do about that? We want to make sure that those outliers are included. And Yuta talks beautifully about how we can, if we bring those outliers to the center and we design for people that would be previously known as outliers as though they are the center, then this design is going to work for everyone. Does that make sense? That's what we want to do. So exclusionary design matters. We need to call it out when we see it, and we need to know why it's not working. And the thing we also have to bear in mind is that sometimes it's not intentional. Often it's not intentional. It's not like some engineer sits in their little cubicle and says, by gosh, I'm going to make sure that these people can't use this. They don't think that way. But because of our own inherent biases, because of our own ecosystem, how we grew up, how we're educated, we don't necessarily think about all the little bits and pieces that all of us in this room think about on a triple times daily basis because it's just not right in front of them, okay? So, I'm going to talk about 3 important human factor strategies to avoid exclusionary design and talk to you about some of the things that we're doing and why I think it's important. And I have to give a shout out to my friend Brian up in the upper left corner. He has taught my clinic team and myself more than almost anyone we've ever met in our years of doing this, so had to give him a shout out. All right, so first thing that is critical is user experience and usability testing. Who knows what that is? Okay, good handful. So one of the things that's now becoming more commonplace, particularly in mainstream industry, is the notion that we need to include the end user in the design process. We know that. We've been all about inclusion our whole lives, right? Well, one of the things I noticed last year at CES in Las Vegas, that massive tech conference that's absolutely crazy, I noticed something that really gave me pause, and that is there are tons and tons of huge corporations developing technology for aging. And they're doing it without any knowledge of HIPAA. They're not doing it with any knowledge of privacy concerns. They just don't know what they don't know. And so I was asked to go and evaluate a number of products while I was there, which I did, and it was shocking. So on the one hand, we have all this mainstream deluge of technology that's coming at us, and then we have our groups here that are trying so hard to make it work for other people. So it's a combination. But I will say companies like Microsoft, IBM, a number of these folks are beginning to really include end users in their testing. So what is usability testing? Quite simply, it's taking a product and determining, what are the functions of the product, what are the tasks you have to do in order to operate the product, and then you create this task list, you bring someone in, and you have them go through the process of using the technology the way they might use it at home. Usability testing can also encompass not just the technology itself, but it can also include the technical manuals and the technical support that comes with it, so you can actually do a usability study on the technical stuff. My favorite was a pill dispenser, and I swear the manual was in 3-point font, designed for seniors and those with visual impairments, not to mention just normal people. So things like that are really critical. And user experience is something we've been doing for about 10 years because 2 RERCs ago, one of this big grant that we have, we realized that all these products on the market, even products manufactured by assistive technology companies, had not been tested by and for the very people they were designed for, not to mention things like microwave ovens. It turns out that people with disabilities use the same darn things we do. They use alarm clocks. They use microwave ovens. They use dishwashers. All of these things were out there, but there really was no data on how useful and how usable are they for these folks. So we started doing mainstream products in the first 5 years. I think we did like 50 products that we tested. Most interesting had to be smartphones. That was quite fun. Now in this last 5 years, we've been really looking a lot at apps, and particularly social media apps, Instagram, Facebook, all of these types of things, Pinterest, the types of things that we all take for granted and we use as a very important part of our social fabric, right? But how useful and how usable are they, those simple apps for people with cognitive impairments? And we've been learning lots and lots of interesting stuff. So strategy 1 is to really understand those human factors that are involved with people with cognitive impairments in particular for us. What evolved out of these first few years of usability testing for us was a recognition that the interface that people use for these technologies, these apps, these whatever, just are really difficult for people with cognitive impairments. And so strategy 2 we came up with and we are implementing is this notion of really doing deep usability, user experience testing. What does that mean? Well, let's see what my next slide is. We want to know what specific, very specific user features impact technology use, right? And my hypothesis is that when you look at your smartphone with all these buttons on it, for someone with a cognitive impairment, how easy is that to understand if you get it right out of the box? And then you start getting apps added to it, and then you start looking at these things. So we had a lot of concern about how does that work. The other concern, and I'll give you an example of one study we did, had to do with seniors voting. So of course the federal government decided a few years ago it would be very important to ensure that everyone in a nursing home or assisted living center got to vote independently. Agreed, right? So they put some money out there to get these votes, and they had us do a study. We did this in 3 locations across the U.S., and we looked at tablet devices with a voting ballot on it. 85% of our users made more than 5 errors with the user interface. Not good. And do you know why? For seniors, as they age, their skin gets drier, and the capacitance decreases. So when they're using a touch screen, it's very difficult for them to access the touch screen. We need a new touch screen interface, right? So that's a big one. Secondly, when we work with people with cognitive impairments, we see similar things with some of the different diagnoses. We see people who struggle with capacitance in and of itself. So we wanted to look at these features and get really into it. And so what we wanted to do, what we have is a simulator that we have built that allows us to reconfigure all these features and parts that you see on a typical touch screen. And this is our simulation 1. It's very simple. And the only thing the end user is told is that they need to press the button that's different. Find the one that's different. And so there's an active button and there are 3 inactive buttons. You'll notice there's equal spacing, there's equal size, they're centered on the screen, and they're just pretty prominent. We wanted to take away everything that might interfere or distract from what we were trying to look at, okay? And here's the kicker. These variables, these values, these things that we're looking at are based on industry recommendations for how to build a user interface for the average Joe. Okay? I would like to point out that these user interface manuals and these design manuals that everyone uses were just put together by teams of engineers in various companies. It's not like they're based on science, but they're based on things like pretty design, good design, the things that they know and know well. But when it comes to our folks, it can be a little bit different. So in this level 1, simulation 1, we're looking at the button itself, how big it is, how far apart it is, what the target asset ratio is, and that means what's active within the button and around the button. So sometimes you touch the edge of the button, okay, just those little simple features. And then what we're working our way through is the different ways we can use touch a button. So we all know how to do direct touch the button, but now there's swiping. There's squeezing, there's pinching, there are all these different things. And so what we're able to do with our simulator is we can log time on task, we can log error rate, we can log pressure, what type of gesture is being used, and what happens when the person is doing this. So my other hypothesis, we always talk about an N of 1, that we need to customize features for each individual person. The truth of the matter is, we all kind of have psychological or neuropsychological profiles. So we spent over a year developing a neuropsychological test battery with our neuropsych department, some incredibly smart folks, that we are now administering to every single subject who comes in to do user testing or this simulation user interface testing. So my theory is at the end of the day, we're going to find that there is a bit of a cognitive profile type, which might encourage us using edge technology to have the technology self-populate iconic features or interface features that work, are a good starting place for that person with a cognitive impairment to get started. Does that make sense? Because right now, when you just hand somebody out of the box a device, our out-of-the-box testing has just been sad when it comes to tablets and phones and things like that, and it's how the whole world interacts, right? So basically what we're looking at is these various variables, and we're measuring as our dependent variable time on task and error rates. Now, so what we can do is basically machine log all of this data on every single button press. There's like 250 button presses per simulation, and we can then get some idea if there's an error or not, what they were doing. And then we can look at our cognitive test battery, and we can do correlations between these errors and their particular cognitive profile. Our goal is to eventually take all of this massive data and bring it back down and see if we can come up with just a few question types, if you will, or a few activities that someone might do when they sit down with a touch screen that would then encourage this uploading of a user interface that is more useful for them. So that's kind of our goal with this particular project, and one we're pretty excited about, to be quite honest, to see what we're seeing. But there's also a third strategy, and this is something that I see is totally missing in mainstream large-scale companies. Something that I'm working on is that in particular, when we're working with people with cognitive impairments, it does take a village. So yes, they must be included in usability and user experience testing and in the design process itself. But also, people who are care providers and clinicians make a difference. So family care providers, people that get to know these people inside out, day after day, that can really say, no, this is going to work, no, this isn't, here are the things that concern me. And secondarily, and perhaps most importantly, who sets this stuff up? It sure isn't the engineer that designed it. Nope, it comes to the care providers in some sense, right? And these folks are left struggling with what is theoretically intuitive, but turns out not so much. And then, especially if we have to set features and we have to do all these things for folks with cognitive impairments, it makes it really, really difficult. The other thing that I'm really learning, because I do see companies now that are starting, particularly AT companies, starting to include care providers, is the need to include clinicians as well. And so, as I said, care providers know the pain points. They know what may or may not go over well. They know what if it's a community living environment of some sort. They know if there's small kids in the house that are going to disrupt X. They know these things, and they can be very critical to helping designers think about things they might not think about if they only talk to the end user. But here's what I'm really, really starting to understand as well. Many care providers, and certainly clinicians, know the trajectory of cognitive impairment lifespans. So, for example, there are acquired cognitive impairments. There are developmental disabilities that we're born with, and there are degenerative diseases and things that happen to us. We know in Down syndrome, for example, that 20% will have coexisting conditions, comorbidities with autism. We know about that amount will also develop early onset Alzheimer's, right? So one of the things that particularly families who are just growing into living with someone with a disability, they can't necessarily see the trajectory of what's going to happen across the lifespan. And this is where I truly believe clinicians are critical, along with care providers, to fill in the missing pieces around technology design and development. Because we know what might happen. We know what happens if we're older, our parents are becoming older, and the person with a cognitive impairment still living at home and still needs a lot of care. We know what happens with frail elders, and now at this point in our lives, frail elders are being asked to set up and use technology with their child or someone they care for, and that makes it really hard. And there's all of us that have done this know how hard this is, right? And so we have to be thoughtful. So we may have someone who is setting up the technology or embedded within the use of this technology in a very important way, who maybe has a hearing loss, who maybe has low vision, who maybe has general natural cognitive decline themselves, or arthritis, right? And those are features and functions that we also need to bring together and really think about as we think through how we are going to address all of the human factors, not just the individual with a cognitive impairment, but there's this whole ecosystem of human factors that we really need to be addressing. We have all this data. How are we using it? How are we thinking about ways we can modulate our design in a manner that is really going to be useful for lots and lots of people? And so we know that edge computing has this immense promise, but we have to make it happen, and we have to make it happen in a way that is meaningful and useful. And we also have to take into account, and I grew up in the whole AT industry, typically smaller companies, really immensely devoted developers. People that own AT companies are not in it for the money, trust me, unless you own the wheelchair companies perhaps. But nonetheless, you're not in it necessarily to get rich quick, right? And they really care about what they're doing. So we have our group, if you will. But over here, we have this immense, and I am not kidding, trillions of dollars immense industry and commercial technology who are all seeing what they can do. And so we have to get beyond what we know, and we have to help get that translated and transferred into mainstream industry. Because if you're going to be independent, what are the things you have to do? What do you guys do every week? Well, you have to do laundry. You have to prepare meals. You have to do all these things. They're developing this new technology. They're collecting this sensor data. The classic refrigerator that now knows what's in there, I, for one, will never have one because I don't want them to know what's in my refrigerator. Just saying. They might nudge me a little bit. But the point is, think about all those menus we've done by hand all these years in care provision and how we get this whole production about going to the grocery store and all this. Well, the refrigerator can now do an order to the store and it can be delivered, right? Okay, but how is that going to work for someone with a cognitive disability? That's what we need to translate and transfer to these mainstream companies. I saw one product, and I will not name the company, that absolutely made me crazy because it was a tablet device with internet accessible video streaming. And they were selling it to people my age who have elderly parents. And the concept is, look, you can hang this all over your parents' house, and then you can just tap in and watch them all day long. It's kind of like when your pet's at home alone. Well, now you can look at your parents' home alone. No consideration whatsoever for privacy, HIPAA, pick one. You know, you can nag your mom to take her pills, whatever. And it's very inexpensive. And I can see millions of people buying this. But here we are sitting over here in our safe world trying to think about HIPAA and all these other things when we have this mainstream industry that's just taking off. And so we need to be thoughtful about this, and we need to make it happen in a way that's real. We need more data. We're just one shop doing this work. We need lots more people to really be doing this user experience testing, usability testing, and certainly we need to dig deep into these specific user interfaces and the cognitive profiles so that we can begin to pull together all of this data, and it can be embedded within edge computing design. Because what this can enable us to do then is bring that outlier that Yuta talks about so brilliantly to the center, design for that, and then it's going to work so much better for other people. Now, one of the things, I mentioned the ERC planning grant we had with Georgia Tech and University of Delaware. We're going to be over the next year looking for partners, both industry, community, and research partners, to propose new projects in edge computing. So if anyone has an interest or just curious about it, I'm happy to talk about it. I'd love to talk to you about it. So I was told I had to keep this to 30 minutes. I'm doing my best. There's a few minutes left. Does anybody have any questions or comments? Because I'd love to hear from you. Yes, sir. It absolutely does, and there's two issues there. One, blue is the widest color prism, so that's why we chose blue. Two, lots of people with cognitive impairments, it's really difficult to test their vision. So in our neuropsych battery, we have a visual perception test, we have a color perception test, and we have some other things so that we can hopefully dig into that a little bit better. It's a great question. It's one we really struggled with, which is why we had our neuropsych guys help us figure it out. Exactly. Right. Right. Yeah, yeah. And so what we want to do is dissect it down to its barest minimum, and then we'll start building up, if that makes sense. So we expect this to take a while. Yeah, yeah. So it's important, but I think it's important to do this and to have more people doing it, frankly. Anything else? Comments, questions? Yes. Yes. One of the things we talk about in bioengineering and in our design classes is inherent bias. Okay, who typically does design work? Does anybody have a guess on that? Engineers, males. How old are they? 30s, 20s and 30s. That's kind of mainstream engineering design. They bring to this, these kids today, and I say kids, I apologize, these young adults, this is the ultimate first generation that does not know what it's like not to have technology. It is so intuitive to them that they bring to it their inherent biases, is for number one. So they don't even think about, they don't know what they don't know because they don't know any differently, right? And they don't understand the experiential knowledge that people in particular with cognitive disabilities have, which is why I think it's so critical to have the care providers and clinicians involved in the design process. You're exactly right. And I saw another, yes, sir. Oh, yep.
So one of your main points throughout this talk is talking about how you get this data to all of these companies, et cetera, doing this stuff. Yeah. And I wonder if you can talk a little bit about how you want to make that communication, because you're going to be pulling in lots and lots of data if you have other people building these things. How do you get Apple or Google or any of the smaller companies that are building these apps? Mm-hmm. How are you communicating this information to them?
A couple of ways. Number one, I am blessed. When you're around long enough, you get to know people. I'm blessed to know most of the leaders of the accessibility initiatives in the mainstream companies and the big companies. I'm also getting, the Consumer Technology Association puts CES on every year. And so they fly me out, and this year I'll be addressing the board the day before CES to really get an opportunity to talk about disability and inclusion. So that's on kind of a grand scale, if you will. On the lower scale, what we are doing, we're actually working on a reporting format now. We're using, it's an ISO, standardized usability reporting format, that we're creating reports on the technology. And so we're debating, we're working with both marketing people within a company, and we're trying then also to get them to get us to, or their lead R&D designers for the products we're testing. But there are how many products out there, right? So we have to approach it top down, bottom up is kind of how we're doing it. We have to get our industry, the AT industry, if you will, or those of us that care about technology and disability also engaged, because it's this mammoth rock straight uphill, right? But we're doing, the other thing we're doing, and we were blessed. There's this guy named Bill Richardson, who was, he was one of the original guys at Sun Microsystems, and he's retired here in Colorado. And Bill spent a Thursday a week for a year with my team, coaching us on how to change our language and how to talk money and return on investment. And so when we approach any of these companies, we don't talk about these people with disabilities and the need for inclusion. We talk about return on investment. And we talk about market share, and we talk about how much more money they can make by doing this and how their stakeholders and shareholders are going to benefit from this. We talk about the cost of retrofitting. If your device doesn't work, then what it costs to retrofit. So you should hear me. It's pretty funny when I get into that mode. It's not here. It's not how I talk here. But thank God for Bill Richardson. He taught us a lot, and that has given us some bandwidth that I don't think we would have had otherwise. So another hand. Yes, sir. Yes, Scott.
So this is a basic question, but what you're envisioning in the future is when you buy your iPad or your phone, you pull it out of the box, and instead of having to maybe calibrate the screen, you're going to possibly go through some kind of a assessment on there to determine size of icons and all of those things.
That's our goal.
Okay.
Yeah, because it's personalized. You know, we did that single sign-on profile thing for a while where you could set your configurations, and then you could, theoretically, it would be available to you to download at any, whether you were an ATM or a tablet or whatever, and I'm probably not saying this all very clearly. And that's difficult to make accessible for everyone and for everybody to work together on that. So yeah, that's the concept, that you would maybe have 4 or 5 things you do, and then your device is set with a baseline. You might still need to tweak, for sure.
Thank you.
Anything else? You guys were awesome. Thank you for coming today. I'm going to let you out of here.